All right, so someone asked me for hydroboration reaction mechanism, which is whenever something reacts with first BH and BH3 and second H2O2 and OH minus. So if you have an alkene, it's always going to add in the syn position, so that there will be an H plus and an OH minus it's going to add in a syn position. And also it's important to note that it adds it, the OH minus, let me write this better, OH minus, on least substituted carbon. Okay, so that should be fascinating because anything else we've talked about hasn't had that. Well, let's talk about the mechanism. You do not have to know this mechanism, and hopefully you will be relieved, because by the end of this video, you're gonna be like, what just happened? It's pretty annoying. Okay, so the first thing that happens in the first reaction when you're reacting it with BH3, so we got some kind of alkane, let's go ahead and react it with BH3. So H, H, H. Now boron here is lacking in electrons. Doesn't have an octet, for example, and it could use some extra electrons, even though its formal charge is 0. And because of that, what happens is this carbon right here, the least substituted one, is going to grab that boron. Okay, so this electron dense area over here acts as a nucleophile, it grabs the boron. But when it does that, this hydrogen then is like, hey, I don't need to be here because now boron's got 3 bonds. It's still got a 0 formal charge. And so those electrons from in that hydrogen go down here. Okay, and what you end up getting is a new hydrogen, which would be right here. And in fact, I'll draw it for this part. So let's go ahead and say it ends up on, if you had a chiral center, it would end up on a dash, for example, or a wedge. Wherever it ends up, the BH2 would be on the same thing. Okay, so now that we have this, let's talk about what happens next, where you react it with H2O2 and OH minus. So BH2 in and of itself isn't a great leaving group, but we'll talk about how to get it to leave. And again, it's not a great leaving group because it's already pretty happy with 3 bonds. So let's go ahead and talk about the side reaction, which is happening with H2O2 and water. So H2O2, hydrogen peroxide, kind of looks like this. Okay, where actually these both would be 109.5 degree bond angles. And it reacts with an OH minus. Okay, and what happens here is that the OH minus is like, hey, I'd like to become water. And hydrogen peroxide's like, that's cool, dude. These electrons will go here. So essentially you get this HOO negative thing plus water. And this HOO negative thing is pretty important. That's kind of the reason this reaction occurs the way it does from here on out. So it comes all the way over here and attaches to the boron. Okay, so now you have, and I guess I'll just keep the wedges and the dashes just to clarify things in case you have something that's a little more stereogenic. So we have a boron with a hydrogen, and now it's got this whole OH thing on it. And boron's now got lots of electrons, so it's got a negative charge. Remember, if you ever forget, valence minus sticks minus dots. The number of valence electrons it has is 3. It's got 4 sticks touching it, so 3 minus 4 is negative 1. That's why it has a negative formal charge. Okay, so this is where things get weird. This carbon right here is like, hey, I would actually really love oxygen instead. I'm not cool with boron. Boron's kind of, I don't know, boring. So it's like, you know what? I think I'm gonna take these electrons and grab that instead. And because these are both on the same side, it still ends up on a dash over here. So it grabs these electrons, but here's the trippy thing. When it does that, then this oxygen would be positively charged normally, right? But instead what happens is these electrons are like, I'll go back here. I didn't mind being an OH minus, and they pop back. All right, but the oxygen and the boron here are still bound together, okay? So what you get, y'all, you still have this hydrogen here, and now you get, on the dash, an oxygen bound to a boron with 2 hydrogens. And you have an OH minus. Okay. And now the OH minus is like, actually that boron looks cool because it still has 3 bonds. This is very strong nucleophile, right? So this is nice Lewis acid right here, BH2 with an O. So this thing grabs that, and these electrons pop onto there. And now we have added this H, and we simply have an O negative here. Okay. And I don't know if you remember, a long time ago we had water up here that we made as a product. So now this water comes back in, and these electrons grab an H, and that pops back on there. And this is how you end up with the least substituted carbon getting an alcohol in a syn position to the hydrogen. And that is how it is done. My least favorite reaction in existence.